Hey guys, my name is Shashank,
My name is Pranav.
and our final project was to make a smart security camera.
So basically, our inspiration for this idea is that there's many smart cameras and doorbells around that allow homeowners to like view their house, whether they're not home or if they're on vacation or some sort. And we have like in like the market, we have many cameras that can identify like different humans and objects based on like images, and we wanted to replicate something like that using FPGAs to track humans and so forth, detect them.
So for our general system description, idea is to basically just make like a Petal Linux application capable of recognizing an external webcam and capturing frames live to like basically stream it and process that through a machine learning model. Uh, in our final product, we ended up using a Linux host machine, like an external Linux machine, to host a custom Python program that we made, which consists of an object detection and object tracking program. Um, Basically, if a human is detected, the human with the most probability detected with the Ziola model would be the only one in focus, and that individual would then be tracked as they moved across the frame. We also wanted to enable some controls with some other PMODs, such as the joystick, the servo, and the OLED, to allow the user to have more control over the system, as well as to incorporate some like automation techniques that will allow the camera to move in accordance to a human's movement. Basically, we just wanted to make an auto tracking algorithm in order to track our target human.
Yeah. So basically in the problem solving area, once again, this project is very security based. So this can be used in like several security systems as everywhere uses cameras. So like homes, schools, airports, etc. Very broad area. So for example, like homeowners specifically can like detect when there's someone who's outside their property or within their property so they can get a little notification or something if they were using this and they can track that using the camera. Also, we have the capability of being able to track people and humans specifically automatically, as well as a manual mode, so operators can manually survey the area and track humans. And obviously, yeah, the end user can be any place where that requires like better security, especially like schools and public spaces.
So this is just like a general system block design. Didn't really since we have like two separate portions that didn't go too specifically into like the Vivado design and stuff. So here we have like one Zyba board that hosts our Petal Linux application, which is capable of recognizing external USB devices and hosting the webcam. And basically, we're able to capture live frames from this, process them, and send them over to a Linux machine over TCP communication protocols, basically Ethernet. This Linux machine hosts our Python program that's responsible for both object detection and tracking. Uh, and based off of where it's tracking said human, it will send commands over TCP again to our second Zyba board. And in order to inform the motor how much to move or like which direction to move in order to continuously track that human and keep them in the center of the frame. The second Zybo is also responsible for controlling many different peripherals, such as the OLED, the Con3, which is responsible for like servo motor control, joystick, and also hosts its own TCP server in order to properly establish this connection with the Linux host machine. So some implementation challenges and choices, right? The first main challenge was the Petal Linux application. The first idea that we had was to actually host the model weights directly on the Zybo board. However, um, there's a lot of problems with that. So first off, models are pretty computationally expensive. So we wanted to make an optimized version. So that mean we use like something like Onyx. We basically convert the weights to like Onyx weights in order to make them more optimized. But this would mean we also need to make like an Onyx runtime engine on the Petal Linux application itself, so that we could integrate it with other C applications to capture images and process them live, right? However, this was very difficult. First off, there was a lot of dependencies. Spent about like 3 days just hunting down different kinds of dependencies that we needed to install. A lot of different like permissions that we just didn't have in order to install our own things. Uh, and there was just a lot of things that we just had to take into account that we couldn't. It resulted in just aimlessly hunting down one path. So we decided to switch over and pursue a different way of live streaming and capturing video. And this was using TCP connections that we can connect to a separate Linux machine and send these images. We also ran into some challenges in just capturing the frames from the external webcam. So first off, there was some just like base problems with getting the USB working. A lot of stuff we had to play around with in the kernel space. After that, there was also the problem with the camera just drawing too much power from the board. Uh, from the onboard USB ports, and that was causing the board to reboot every time we wanted to even capture one image. As a result, we ended up purchasing a small external powered USB hub that would externally power the webcam while also allowing it to be connected and transfer data to the Zybo board.
All right, yeah. So another challenge, I guess we can say, and the choices that led from that challenge was certain part limitations. So because we were using a motor, there was two options. Originally, there was the one that we were looking at, which was the DHP1 P mod, and that allows you to control like a motor based on the speed and so forth. Um, and there was example coding, so everything about that. So when we originally tried to implement that, we realized that the functionality of the DHB1 PMOD is that it can only use bipolar stepper motors and DC motors, like two DC motors. But bipolar stepper motors were not accessible, and DC motors required extensive like a breadboard and a different like functionality in order to power it properly and control it. Um, so we decided to switch to the Con3 PMOD, which was a PMOD that can simulate like a PWM signal. However, it did not have its own like IP block or anything or example references as it uses a regular like GPIO block on the IP like IP block diagram. So that left us with like the challenge of figuring out how exactly it worked using references online, which wasn't too horrible, but it did add like some time. We also coded up a PWM signal ourselves, so our simulator ourselves through Vitis, so that that Con3 PMOD can send signals to a servo motor. However, once again, we come to the part limitation issue was that we needed servo motors, and the servo motors that we did have was um, all 180 degrees. And what we needed was to find a servo motor that can go 360 degrees enabled so that we can track um, people and humans and control speed. All right, so interfacing PMODs with Pentalinux. So this was really difficult. Originally, we had the idea of just using a PMOD controlled through Vitis directly and just uploading whatever we had on the bare metal onto the board, um, and then trying to use the Pentalinux at the same time. However, you can't do that because they would overwrite each other in the PS, and that makes it so that you can't use one or the other. So that makes it quite impossible to do. And that left us with ideas like instead of using a BSP, we used our own custom XSA from the Vivado build, bare metal build, and tried to use that as our base. We got it to work on one board. However, combining it again faced a lot of problems as there was a lot of like customizations that you had to make and configurations and stuff that wouldn't work for with the YOLO and etc. Finally, we or second to last, we tried to do a UART between two boards. However, that also faced problems as a pedal Linux board cannot establish a connection as it was hard coded to use just one external Linux machine and use UART that way. So we didn't have another UART port available. So we ended up communicating on TCP protocols using Ethernet, which ended up being the best way to do it. It had some problems like Shashank talked about, but it ended up working.
So, final summary, mostly a success. We were able to live stream video and process them through our like detection and tracking models and allow the mover to move on its own. We were also able to take over manual control and do it ourselves as well. All our PMODs were functional. We were able to like display our intended output and basically be able to like have a working product. However, we couldn't really produce our original design to have everything on one Zybo. Had to use multiple machines. So in the future, what we would like to do is be able to host it on one main machine rather than have like three separate devices. Another issue that we were having was that we weren't able to get better frames, and it would just like the stream would kind of just freeze after around like 30 seconds to a minute, uh, due to some buffer issues we were having. Couldn't fix that and would like to fix that in the future. Finally, there weren't that many resource limitations because we were using multiple devices, but it would be difficult to having them work on one device since there was just so much running, such as like the model weights, the actual webcam streaming, as well as PMI control. Finally, a little bit of time constraint. Maybe could start a bit earlier, but we were facing some issues with just getting the overall Onyx runtime engine working and just learning pedal Linux on the fly. So yeah, these are just some of the references we use to finish our project. Thank you for listening. Have a great day.
Thanks.